So we've got our last topic, and this failover clustering for Hyper-V is something that you might consider including in your assignment if you're giving us a Hyper-V solution. Okay. So let's have a quick look at this. It may be, it doesn't have to be part of your assignment, but if it's not part of your assignment, it's certainly something that probably you should include as future improvements. So it's a short topic, and it's something that we sort of discussed in VMware. So like we've been saying, everything we're doing in this Hyper-V, there's some sort of equivalent in VMware. So the failover clustering is similar to the VMware HA, high availability. So basically today we're going to look at configuring and using shared storage. Obviously the HA or this failover clustering doesn't work unless you have shared storage, because how do you restart a virtual machine that's stored on the local server of a Hyper-V or EXXi server if that EXXi server has failed? You can't. So no shared storage, no high availability, no failover clustering. And then the other thing we'll be discussing is implementing and managing the failover clustering with a Hyper-V. So let's get started straight into it. So Hyper-V supports SMB free or newer. So if you haven't heard me mention that, I think I've mentioned it several times. SMB free is basically Microsoft's share for applications. It's not your normal share. Okay, you can't just right click and share this folder and that's it. That's just a normal SMB share, but you have to go and share it through your sharing area. So let me see if I've got a virtual machine with server on there, and we'll see if I can just quickly show you what so forget the fact that this is called a Golden Master. I'm using this virtual machine for many purposes. When we say share for applications, I'll show you what we mean. So it's a special share, makes it makes the Windows share into a share, SMB free share. Okay, so obviously I was demonstrating something else here with this machine, but if I go to my C drive, okay, I'll actually go to let's go. I know it's not, D drive is not formatted. Come on here, come on in, Robin. So D drive is not formatted, so let's just go stick with the C drive. Okay, it doesn't matter. I'm just going to create a new folder, and we're going to call it VMs. All right, so that's the VMs folder. Just pretend this is on a shared storage server, and basically, if I have that folder and I want to turn that into a SMB free share, we go to the server manager, we go to the shares, and we now create a new share, and we have to do it this way. Okay, so it's not a quick share. Quick share gives you just normal sharing. If we look at the advanced sharing, this profile offers additional options to configure. That's not it. It's the share for applications. Okay, if we read it, if you look at this, it says this profile creates SMB shares with settings appropriate for Hyper-V. That's what we're interested in, but also other databases and other server applications. But the key thing we're interested in there is the fact that it's a share for applications. So if I actually go through and create this share for applications, it's on server 1, and we'll put a custom path. We'll browse, we'll go to the VMs folder we created earlier, we'll select that folder, we'll finish off the wizard, and we're going to create the share name. We're going to call it just the description, Hyper-V shared storage SMB 3.0. And this is the path, this is the share name. These things are not necessarily anything new. And then when we create this, there's a couple of things that we can choose. We can actually encrypt data access. This we all know what encryption is. When you when enabled, the remote access for this share will be encrypted. This secures the data against unauthorized access while the data is being transferred from the share. If this box is checked and grayed out, an administrator has turned on encryption on the entire server. So what does this mean? This means basically when someone's accessing the share remotely, the transport of data is encrypted. Okay, that's what it just means. We don't need to turn that on if you don't want to, and this is where we can set the permissions. If we go back to our PowerPoint here, okay, so we need full permissions on the NTFS server for the Hyper-V administrator. So obviously we would configure these groups and give them full permissions. But if, let's just pretend we've done that, we create, and basically that's done. Okay, it's not super hard. Okay, it's not super hard. Okay, to create this, but you just have to create it in this method rather than the right-click share method. Okay, so let's get back to our PowerPoint again. So Hyper-V supports SMB free share or newer share. Hyper-V uses file share. Hyper-V uses file share is used as the cluster shared storage. Like I said, if you have this failover cluster, you need a shared storage. So it's uses it's a continuously available share recommended. So obviously continuously available is talking about high availability service, redundancy, built-in, and all those kind of things. All virtual machine storage can be on a SMB share. Configuration files, the virtual hard disk, and the checkpoints or snapshots. So you can put all of those type of files on the SMB share. So the SMB share for application profile should be used. We should not turn on the access-based enumeration or share caching. So that's not, because share caching is basically caching the files so that when you access the network share, you already have sort of some of the files there. But that's really good for file server when you have static files. Files are not changing much. So when you click on it, you can see the files straight away. But obviously for virtual machines, the virtual machines are changing all the time. So how can you cache any of those files? Okay. So we need full permissions on the NTFS folder and the SMB share for the Hyper-V administrator's account. And we also need the computer account of the Hyper-V host. And also we need the Hyper-V cluster computer account if it's a Hyper-V cluster that we're setting up for. So using scale out file service. So if you've never heard of the term, I'm sure you have. There's what's called vertical scaling and horizontal scaling. You might have heard of this in your cloud subject. Yeah. Scale out is horizontal scaling. What does that mean, really? Let's actually get a picture to help us demonstrate this. So if we actually go and just go horizontal scaling versus vertical scaling, hopefully we can find something that's how do they compare. Let's look at that one, for example. And let's see if we've got a picture to help us describe it. So basically, if we look at this, this probably is a good picture. So horizontal scaling is instead of having one server with one CPU, 8 gigs of RAM, 1 terabyte of SSD storage, you have lots of servers, a pool of servers. So that's horizontal scaling, where you add more and more servers. This is equivalent to what we just talked about scaling out. Okay. If we talk about vertical scaling, so instead of actually adding more and more servers, you just make this server bigger and bigger. So instead of actually adding 3 more servers, we're just making this server, we're adding more CPU, adding more RAM, adding more storage, and so forth. So that's called scaling up. Okay? So this is vertical scaling, this is scaling up, but horizontal scaling is scaling out. Okay, what are some of the this is examples. So scaling in. So this is scaling in, and this is scaling or scaling out. And so let's get back to our PowerPoint. So it's recommended that we use a scale using the scaling out file server cluster, a file server cluster for general use. Some of the benefits of a scale out file cluster include active file shares and increased bandwidth. So if we have more servers holding the files, okay, it just means we can access the files from 2 locations. It's like having mirrored disks, right? And that increases the bandwidth. And also, if it's an active, it just means that they're mirroring each other, okay? So we can do check disk. So check disk is like a scan disk with 0 downtime, so we can actually check one of the copies without turning off both copies. We can do one at a time. We can also use a CSV cache, so that's a cluster shared volume. And it's a simple management, and there's automatic scale-out rebalancing, where clients redirect to the best node for access to the share, avoids unnecessary traffic redirection. So basically, the clients are sent to the best node at the point in time instead of just one node, and then being redirected. A failover cluster runs inside, can run inside a virtual machine. A shared virtual disk is used as a shared storage. A virtual machine do not need access to iSCSI or the fiber channel SAN, and it's presented as a virtual SAS disk, and this can be used only for data. So what does that mean? So it means that we can actually mount a virtual disk from a SAN or a iSCSI shared storage, and we can just mount that as a disk in the virtual machine. Okay, so that can be used for data, which basically means if the virtual machine or even the host of the virtual machine fails, the data is still safe, isn't it? The requirements for a shared virtual disk is that the virtual hard disk must be in the VHDX format, so that's a generation 2 virtual machine, and it's connected using a virtual SCSI adapter, and it's stored on a scale-out file server or a cluster shared volume, and you have to have 2012 or later. All right, so let's talk about failover cluster. So like it says here, it actually compares to high availability VMware high availability. So if we just describe it, it's basically exactly the same, okay? So let's describe it. So we have a shared storage. This is a cluster shared volume, and all these virtual machines are stored here, and all these black boxes here are Hyper-V hosts. They can all access it. Easy. So they can all read the virtual machine files, like the VMDK files, the VMX files, or in this case, the Hyper-V files, and we've got the VHDX files that they can access. So the idea is that these hosts are running, and we have these virtual machines. They're all running, and you can see there's some spare capacity. Okay, so there's spare capacity. This cluster shared failover cluster or the VMware high availability does not work unless you have spare capacity. If you don't have enough capacity, it cannot work. So it can support up to 64 physical servers, so these servers, and it can protect up to 6,000 virtual machines. It's built-in hardware and software validation, so we have to validate that these hardware can meet the requirements. Okay, so if they don't meet the requirements, they will be rejected to performing the cluster. We need to have shared storage, any of these type of shared storage, and basically, let's see if there's a better picture. No. All right, let's just go here and describe it. If one of these, let's say this Hyper-V server's got these 2 virtual machines running on it, okay, it's using the CPU, it's using the memory, it's using the network interface here. If this Hyper-V host fails, for whatever reason, it could be that this network cable to share storage has failed, it could be that the network cable to the production network has failed, it could mean that the hardware has failed, it could mean that this hardware just turned off unexpectedly. So the key thing about this failover cluster and the high availability of VMware is it's for unexpected failures. Whereas the vMotion, the live migration, they're really good for something you expect, something you expected, like you're going to do a restart because of an upgrade or a patch. Then you can actually just transfer the virtual machines off, no downtime, etc., etc. But this is to protect this, and this high availability is protecting against unexpected failures. So if the hardware failed unexpectedly, these virtual machines go offline, obviously. But because they're part of a failover cluster, these other members will recognize that this has gone offline with the aid of the heartbeat. If you remember, we talked about the heartbeat, where it sends a little bit of information, I am alive, I am alive. And if the other member is not getting this I am alive from this particular node 1, then it will assume it's dead. So what about these virtual machines? If these virtual machines are what we classify as protected virtual machines, then they are restarted elsewhere, wherever there's capacity. So that means there might be maybe 10-minute downtime, but these services will be restored automatically without our intervention. So this could be at 2 a.m. in the morning. Our company is not doing much work, but our customers in North America are accessing our let's say, if we talk about the scenario of the piece confectionery, they're accessing our services in order to purchase and order confectionery to the North American market, which is one of the areas we want to try to get in. So if they're trying to access these services, they're going to be offline, and it's 3 a.m. in the morning in Australia. But because this is automatic and these protected virtual machines gets restarted, that service is restored with a small delay. So when we're configuring the high availability virtual machines, the high availability wizard will actually determine the virtual machine storage is on a shared storage, like I said, cluster shared volume, or a SMB-free continuously available share. We have a virtual machine startup priority, so if there's lots of virtual machines, we don't have to protect all of them at the equal level. You know that there's some virtual machines which are more important than other virtual machines, so we can set a higher priority on those machines and set a lower priority on the other virtual machines that's not as important. So the higher priority is started before the lower priority. So what does this mean? If this one's a high priority, this is low priority, this one gets started first, and then if there's capacity, this lower priority virtual machine would then get started. Okay, there's also no auto restart, or must, which means that this virtual machine is not protected, basically. Yeah, if it goes offline, don't worry about this virtual machine. I'll manually restart it after failover. Okay. Preferred owners. So if you remember when we talked about the vSphere or VMware, we talked about host affinity. If you remember, they want to be on a specific host machine. So this preferred owners is basically the same thing. Virtual machines will start on a preferred Hyper-V host. So there's a couple of settings. So start on possible owners, only if preferred owners are unavailable. If preferred and possible owners are unavailable, virtual machine will not move to other failover cluster node, but not started. So there might be reasons why you have this preferred owners, because this preferred owner might be linked to a specific function. Let's say it's a high CPU, intensive activity that's going on in these virtual machines. So you might want them to be started on this specific Hyper-V because that's got more CPU resources. So we have this possible preferred owners. We also have possible owners, which means that these are secondary virtual hosts that you might be able to use it. So there's also anti-affinity. Remember, if affinity is where you want to be on something, anti-affinity is you want to stay away from it. So basically, AntiAffinity class name, so cluster roles in the same AntiAffinity class avoid the same cluster node. So what does that mean? So if I have two virtual machines which are in the same AntiAffinity class, let's say I've got CPU intensive VM1 and the CPU intensive VM2, I put them in the same AntiAffinity, basically AntiAffinity rule. It means that if they get moved to a different host, they don't want to be on the same host, because obviously they will be fighting each other or competing with each other for the CPU resources. So that's why we might configure this. It prevents virtual machines from running on the same node. And we can configure this in PowerShell or the System Center Virtual Machine Manager. So we're not going to go to the VMM in this subject, but that's effectively turning our Hyper-V virtualization environment into a lot bigger. So for a small company like the Airpiece Manufacturing, you probably never would implement VMM. But for a large data center where you are creating a large virtualization infrastructure, the VMM is like having the vCenter server for the vSphere. So options to modify failover and failback settings. So number of times that to restart a cluster role, we can configure how many times do we restart the virtual machine. We can prevent failback of a cluster role to preferred node. So if it's failed over to another host, we could actually, what if the original Hyper-V turns on again? So if it's a preferred node, it will try to go back there. But we can actually prevent this if we think that's more of a going to cause more of a problem. We can also configure virtual machine policy settings. So these are rules surrounding the virtual machines, and obviously the virtual machine heartbeat monitoring. So if you remember, we talked about heartbeat monitoring. Heartbeat, the idea of the heartbeat, I am alive, I am alive. So if we think about this, the virtual machine heartbeat monitoring, so normally we monitoring the host, because that's how we detect if the Hyper-V server is down. But just because the Hyper-V server is running, doesn't mean the virtual machine is running properly. What if the virtual machine had a failure, like a blue screen of death, okay? So if that's the case, then that's pointless as well, because if that machine has a blue screen, no one notices it, it is not providing a service to the rest of the network, is it? So if that's the case, it's a useless virtual machine. So if this virtual machine is also got a heartbeat, I am alive, and if we're not receiving the heartbeat from the virtual machine, we can say that this virtual machine is dead as well. So in this case, we can actually restart the virtual machine. As you know, if we have a blue screen on a server, restart often fixes it. So if we restart it, it might recover the virtual machine at that point in time. But this requires that integration services to be in the virtual machine. So if you remember, that is equivalent to our VMware tools. So that's going to be sending the heartbeat messages. Well, so let's say the virtual machine is running properly. What if the service has failed? Okay, so you probably see me restart a service, particularly because it's failed or it's not working properly. So what am I saying? So I'm talking about in Windows. You know that these are services, okay? These are services, and if we had a, let's say, a web server installed, there will be a IIS service. But like any program, it could crash. Okay, so it could crash, and what we normally do is we discover a crash service. Let's just pretend one of these. Adobe. Let's try this one. I know that's running, but we can't actually do anything with this one. Actually, let's find this one. We can actually just stop a service, or we can actually start a service, or we can restart a service. So if the service crashed, it's just like closing down killing the program and turning it on again. We know that fixes a lot of problems. That means it doesn't require a full restart. Okay, but what if you're not there to watch it? Okay, so application health detection in virtual machines. So that's similar to the VMware app HA. So instead of monitoring the host now with the heartbeat, instead of monitoring the virtual machine with a heartbeat, we're actually monitoring the service. So we can monitor the service through a service control manager, and we can configure the service recovery to take no action or to restart the computer, virtual machine. If we tell it to restart the virtual machine, then all the services get restarted, doesn't it? And then it's almost like restarting the service like I just showed you. And it recovers those things. So it monitors the event in the system, application in the security logs, and you need the server 2012 or newer. And we can, the recoverable actions include to restart the service, restart the virtual machine, or fail over the virtual machine. So restarting the service is what I showed you. You can do something like that. So that fixes a lot of problems. Don't forget, all of this is automatic. So 2 a.m. in the morning, you're sleeping, this is happening. This is monitoring this, and you can restart the service, restart the virtual machine, or move the virtual machine to another host. What about virtual machine network and storage protection? So basically, what if the host is running, the virtual machine is running, the service is all running, but the network connection is lost. That network cable, someone's accidentally unplugged it, or it's just broken, or something's happened. Okay, well, in that case, even if it's running perfectly, your clients can't access the service, can they? Which makes that service, which makes that server, which makes that virtual machine useless. So what we can do is we can actually, again, fail over. So if we have a failure of the virtual hard disk or lost network connectivity, the virtual machine is moved to a different cluster node. So if that one cable is plugged into Hyper-V 1, and that's failed, if we move it to Hyper-V 2, that network should still be functional, right? The production network. So that just means we recover from, we make that service available again to the clients. You understanding me, guys? All good? All right. What about replicas? Remember last week we talked about replication? So if we've got two failover clusters, failover cluster 1, failover cluster 2, and basically we have a virtual machine that can actually be failed over to the other nodes. But what if we got, what if, can we include a replica as well? So what we got here is server A, and we're creating a replication to server 2. Just making a copy of the video, I'm not running necessarily. But if let's say the server fails here, because of the failover cluster, this server 2 is going to take over, and the replication now is replicated to dysfunctional. So the replica that we spoke about last week, which is talking about whole of site failures, can work between clusters as well, and it can help you protect that. So if that's failed, then it fails over to another host, but then the replication adjusts so that the host here is replicating to this host over another cluster. So live migration, we spoke about this last time. So live migration is where you utilizes available CPU resources on a host to perform compression. The compressed memory is sent across the network faster. It operates on networks with less than 10 gigabit bandwidth, enables a 2 times improvement of the live migration performance. So again, virtual machine is running here, it's stored here, and then there's a migration network, and the memory is sent over as compressed, and this is sort of not running at this time. But then when it actually sends over and it gets to that point where it's almost exactly the same, so that configuration data is sent, the memory content is sent, compressed and sent, and then decompressed obviously, and then when it's all exactly the same, modified pages, then updated pages are sent and changed, and then it switches over the functionality. All right, so that's the last topic of this subject, okay? So all done. it.